Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Open Shortest Path First, otherwise known as OSPF. Specifically within OSPF we're going to take a closer look at how to configure and verify the implementation of multiple area OSPF. We're going to do this on Juniper routers. So as you can see, we have three routers in this network. We have router 1, router 2, and router 3. Router 1 and router 2 are connected to each other via the 12 network. In this lab we are using the concept of logical systems, and we're going to use logical tunnels to connect the logical systems together. So if you're not familiar with logical systems, you want to go ahead and check out my video on how to create logical systems and link them together via logical tunnels. So in this lab again we have router 1 and router 2 connected to each other via logical tunnel 12 on R2. If you see at the top of our network diagram, we have that all LTs, or all logical tunnels, equal LT-120.XX, and so in this case the logical tunnel on R1 is logical tunnel 12, the logical tunnel on R2 is logical tunnel 21. Then we also have a link between R2 and R3, which is the 23 network, so 23.23.23.0/24. The logical tunnel interface on R2 is LT.23, and the logical tunnel on R3 is LT.32. So again, this LT is short for LT-120.XX, and in this case 23 and 32. We also have a loopback 0.3 with the 3.3.3.0/24 IP address on R3, and also on R1 we have the loopback 0.1 with the 1.1.1.0/24 IP address. And we're going to advertise these loopbacks into our OSPF network. We also have router 1 and router 2 that are going to be connected together via OSPF area 0. And then we can see the multiple OSPF area implementation coming into this lab, because we have router 2 is going to be connecting area 0 to area 23. So router 2 in this example is going to be our what is known as our area border router, and an area border router is quite simply a router that connects our borders between area 0 and any other area. So in this case we have area 0 between R2 and R1, and we have between R2 and R3 area 23. So router 2 has multiple interfaces. It has one interface in area 0, and it also has one interface in a different area, in this case 23, and that's what makes it an area border router. Also in this lab we're going to take a look at some of the show commands and show you some of the different commands that you can perform in OSPF to look at some of your LSA information. We're going to introduce some of those show commands to you in this lab. You can kind of see exactly your OSPF database looks like. Alright, so let's go ahead and get started. And the first thing we're going to do is we're just going to set up all of the routers, router 1, 2, and 3. This is going to be a very simple and easy configuration. We're going to do the command, we're going to create the logical systems first, so we're going to do set logical system R1, interfaces LT-120, again the command is set logical systems R1. We're going to first set up our interfaces, so interface LT-120.12, or we could also do that by putting the unit 12, family INET with the address of 12.12.12.1, followed by our subnet mask. Along with that command we're going to do the pure unit 21. We're also going to set our encapsulation to Ethernet. So if you're not familiar with what I'm doing right now, I highly suggest that you watch my Logical Systems Lab, where I show you how to set up logical tunnel interfaces. So it's very simple once you've done it once or twice to configure. Very, very fast. Next thing we're going to do within Logical System R1, we're going to create the interface of loopback 0 for unit 1. And we're going to give it an IP address of 1.1.1.1.1/24. And we'll go ahead and commit this. Next thing we're going to do is we're going to set up router 2. So right now we're just setting up the links between our routers. So we'll do set logical systems R2 interfaces LT120 unit 21. Again, this is the link between R1 and R2. Family INET with the address of 12.12.12.2/24. Also, we're going to use the peer unit statement. We're going to peer to logical tunnel 12 on R1. And then our last statement, we're going to do the encapsulation of Ethernet. Next thing we're going to do on router 2, we're going to set the connection between R2 and R3. So we're going to do set logical systems R2 interfaces LT120. The unit in this configuration are between R2 and R3. The unit's going to be unit 23. We're going to give it the IP address, IPv4 address of 23.23.23.2/24. It's going to be peering to the peer unit of 32 on R3. And last thing we'll do is we'll set the encapsulation to Ethernet. Okay, now that router 2 and router 1 initial configuration is done, let's go ahead and configure router 3. So we'll do set logical systems R3 interfaces LT120. Unit's going to be 32. Family is going to be INET address 23.23.23.3/24. Peer unit's going to be 23. That's router 2. And the encapsulation is going to be Ethernet. So we'll go ahead and commit this. We'll exit out of global config. We'll go under set. We'll do set CLI logical system R2. So again, this is the way we can log into the logical system directly, in this case R2, and we'll be able to verify what we're going to do. We're just going to verify the links between R2 and R1 and R2 and R3. Since it's the, if we look at our network diagram, it's the router that's in the middle of our configuration. We're just going to do a quick ping to R1, verify we have connectivity. Then we're also going to do a quick ping to R3 to verify connectivity. As you can see on R2, if we do a show route, we have the 12 network and the 23 network in our routing table. So we'll do the ping 12.12.12.1. And there we're pinging router 1. We see we have connectivity. We'll also do a ping to router 3, which is 23.23.23.3. And we also see that we have reachability to router 3. So now what we're going to do next is we're going to go ahead and set up basic OSPF on R1, R2, and R3. We're going to advertise the links. We're going to advertise the directly connected links into OSPF between R1 and R2. This is area 0. And we're also going to advertise the loopback 0.1 into OSPF area 0 on router 1. So let's go ahead and get that basic link between R1 and R2 up first. So from router 1's point of view, we're going to log in. We'll go under edit protocols. We'll go under configuration mode and we'll do the command edit protocols OSPF. Then from edit protocols OSPF configuration mode, we'll do the command set area 0 interfaces, our interface LT120.12. We're also going to put into area 0, we're going to put in loopback 0.1. So real fast, we'll just do a show command. Let's go under the top and do show. From router 1's point of view, we have a loopback 0 unit 1 with the one network that we're advertising into OSPF with this statement under protocols OSPF area 0, and we also have the logical tunnel unit 12 that we are advertising under OSPF area 0 with this statement as well. So we have the basic configuration on R1. Let's go ahead and commit and quit. And now we'll go under logical system R2 and we'll get it configured. So from router 2's point of view, we don't have a loopback that we're going to advertise into OSPF, and that's fine for the purpose of this lab. We don't really need that. We're just going to explain to you how to set up multiple area OSPF and show and verify its configuration. So router 2, we're just going to put its logical tunnel 21 into OSPF area 0, and then we're going to put logical tunnel 23 into OSPF area 23. So let's go ahead and get that done on R2. Again, we'll go under Edit, Protocols OSPF. We'll do the command set area 0. So in area 0, we're going to put interface LT120.21. We're also going to do the command set area 23, interface LT120.23. Go ahead and commit and quit. And then from router 2's point of view, to verify the neighbor relationship with router 1, we'll do show OSPF neighbor detail. And we can see that we have a neighbor adjacency with router 1 over the logical tunnel 21 interface. The state is full, so that is good. We also see the router ID from R1's point of view. We see the priority is 128 and our dead timer. We see that this neighbor adjacency is in area 0 with the DR and BDR, the uptime, and the adjacent time. So really good information to have right off the bat. However, we see that we're still missing our neighbor relationship between router 2 and router 3. And this again is going to be in OSPF area 23. So let's go ahead and get into router 3. And we'll set up OSPF on R3 in area 23 exclusively. We'll go under Edit Protocols OSPF. We'll do the command set area, and in this case we're going to do the area of 23, so we'll do set area 23. You can also write it out as 0.0.0.23 if you prefer. So we'll do set area 23 interface LT-120.32. And also we're going to put in our loopback, which is LO0 loopback 0.3. And let's verify that. We have loopback 0.3 on R3, and we have logical tunnel 32. So on R3, if I do a show configuration protocols OSPF, you can see that we have under area 0.0.0.23, again that's area 0, I'm sorry, that's area 23, we have logical tunnel 120.32, which is our local interface between R3 and R2, and we have loopback 0.3. So from router 3's point of view, if I do a show OSPF neighbor detail, we can see that we have a neighbor adjacency between router 3 and router 2 now. You see the address of 23.23.23.2, which is router 2. See our local interface, which is the LT.32 interface. The state is full, which is good. And we see the router ID of our neighboring router, which is router 2. You see primary and dead timers. the priority and the dead timer. And we have the very important statement that shows our area that this adjacency is in, which is area 23. Now that we have the neighbor relationship between router 1 and router 2 and router 2 and router 3, on router 3, if I do a show route, we can see that we are learning the 1 network via OSPF with a route preference of 10 being learned from router 2. Go ahead and try to ping this. We'll do a ping 1.1.1.1. We'll source this from our loopback 0.3 interface, which is 3.3.3.3. Let's do this. Looks like we don't have in router 3's in router 1's routing table, we do not have a route to the 3 network, and that's why our ping failed on R3. Let's go ahead and take a look at why this is happening. Let's go back to router 3 and just do a show configuration. And it appears as though under router 3 we only have the logical tunnel interface. We don't have a loopback. So I don't know if you were watching this and you were wondering why I didn't create a loopback 0.3 interface on R3. I must have missed that altogether when we were under the router 3 configuration. So I apologize for that. Let's go ahead and under router 3, now that we caught our mistake, we'll do the set interfaces loopback 0.3 family inet with the address of 3.3.3.3/24. Oh, looks like we have permission denied. So let's do this. Let's get out. Sometimes you'll see that when you're messing around with logical systems, if you log into a logical system, in this case we're in router 3's command prompt, some of the commands you're going to get permission denied. Not sure exactly why that is the case. However, the way we're going to have to create this interface is go back to the actual physical router and go under configuration mode under the physical router. Do the command set logical systems R3 interfaces the loopback 0.3 family inet with the address of 3.3.3.3/24. Don't ask me why. I'm not sure why that is the case, but now you can see that it took. So if we go back and do a set CLI logical system R3, and now if I try my ping again, so I'm going to ping 1.1.1.1 and source it from 3.3.3.3, see that we are successful. Let's do a rapid count of 1000, and you can see that we're good to go now. So let's go ahead and get out of router 3. Let's go back and do set CLI logical system R1, and if we do a show route now from router 1's point of view, we can see that the 3 network is being added into the routing table on R1 via OSPF. So this is a very simple implementation of multiple area OSPF. Let's go ahead and go back into our lab. Let's go under logical system R2, And if I do the command show OSPF overview, we can see that we now have two different areas under this command. In the output we have area 0. We also have area 23. Another good statement to do, or another good show command to do, is to do the command show OSPF. Actually, before I go ahead and do this command, I'm going to show you that it shows area border router. This is indicating that router 2 is indeed an area border router in this implementation, and that is exactly what we said it is going to be, because it has an interface in area 0 and it also has an interface in area 23. Let's do the command from on router 2. We'll do show OSPF database. We can see that the ABR has two different OSPF databases. It has a database that it creates a link state database for area 0, and it also has a link state database for area 23. And what I want to do is just explain a couple of different types of information that we're seeing in this database. We see the LSA type that it's showing us. We see the router LSA. This is LSA type 1. And we're going to see that all the routers in the area originate LSA type 1s. We also see that we have, in this case, the type which is network. This is LSA type 2, and we're going to see that within the OSPF database that LSA type 2s, when they show up, are going to give us the designated router information. So these LSAs are originated by the designated routers. In this case, if I do a show OSPF neighbor and then look at my neighbor relationship to router 1, we can see that the designated router on the link between R1 and R2, the designated router is indeed R1, and that is our network LSA type 2. That is exactly what it's showing us, what the designated router is. And then our last LSA type that we are seeing with the show OSPF database is the summary type, and this is LSA type 3. The summary LSA type 3 is generated by or is originated by the ABR. And we see that with the advertised router. So the router that is advertising that to us is router 2. In this case, we know that router 2 is the ABR. So for both of these OSPF databases, area 23 and area 0, we see that the summaries are being advertised, are originated by router 2, which is the .2. So a very important command when troubleshooting OSPF is the show OSPF database command. It's going to give you your different link state databases. In this case we have two, one in area 0 and one for area 23. We went over the LSA type 1, 2, and 3, where they originate from, and how to read the show OSPF database output. So in this lab, again, to wrap things up, we looked at OSPF and how to configure it in multiple areas. We looked at the term and explained the term of an area border router. In this case, router 2 was the ABR because it had an interface in area 0, and it also had an interface, a neighbor adjacency to router 3, which was in area 23. We looked at a couple of show commands and explained some of the different LSA types within the show OSPF database command. So that's the basics of multiple area OSPF. I want to thank you again for watching, and I hope to see you in the next one.